fifth grade. Sorry to be reviewing with you today virtually. I'm really excited to hopefully see you tomorrow on Wednesday. We're sending you lots of warm thoughts today, and we're going to do the best we can to review together in this format, and then I'll be available over Seesaw if you need to ask any questions. But hopefully, doing this review together will help. My game plan is to try to run this review just like we would in class. I'll set a timer. I'll give you time to try a problem or two. Then we'll come back together and try it and talk about it. Then I'll give you another few minutes to try it independently for the next problem or so. Then we'll come back together and talk about it. So really shouldn't need to pause this video or anything. Just feel free to let it play as you follow along. And then again, I'll be available if you have any questions, but this should look really similar to your mid-module assessment, so hopefully there's not any surprises on here. So we're going to go ahead and get started. So just like our levels of learning tracker, we go from surface deep into the transfer. So on your mid-module, you saw surface and deep, so I'll be really sure that we talk about those transfer level questions on this review. All right. Starting out, I can estimate the sums and differences of fractions or mixed numbers with unlike denominators. So number 1, it says estimate the sum of the fractions and circle one of the choices below. So estimating again means a guess in a way, but a guess that's reasonable and makes sense. So I'm going to set my timer here. 1 and 2 have the same directions. So you're estimating and then circling. Do you think that either the sum or difference, number 1 would be difference, number 2 would be sum. Do you think it would be greater than 1 or less than 1? So I'm just going to set maybe a 5-minute timer and then we'll talk about it together. If you have extra time, you can feel free to go on or fast forward a little if you need. Alright, so I know I stopped you a little early, but as I was working those problems on the side, I figured you probably are at the same spot I am, ready to move on. Alright, so number 1, estimating the sum of those fractions. There's a lot of information I'm going to take in there. First thing I'm going to look at in making my decision, if this is half, that automatically means it's half of one whole. And then I would be subtracting a unit fraction. So remember, a unit fraction is anything that has a denominator of 1, because it's just one of that whole. So 1/3 or 1/5, or in this case 1/7. So I would only be subtracting one piece of that whole. So if I had a half and I'm subtracting a unit fraction, there's really no way that that's going to be greater than 1. So this would be less than 1. Number 2, This time I'm finding the sum instead of the difference. So I would look at the information that I have here. I already have one whole, and I'm going to be adding on another fraction that's close to another whole. So if I'm adding on a whole and I already have a whole, the only thing that would make sense is greater than one whole when those come together. All right. The next one says I can use the identity property to create equivalent fractions. Remember that identity property tells us that anything I multiply by the numerator, I have to multiply by the denominator, or by the denominator, I have to multiply it by the numerator. So I'm going to give you another, this one probably minute or so, to create 3 equivalent fractions using that identity property. So you're starting with 1/2, and you're making 3 different equivalent fractions. So I should see 3 different fractions that are all equivalent to 1/2. These are all probably look different, so I will come back and give you quite a few when we come back, but don't worry if they're not exactly the same, because remember, equivalent fractions, as long as you follow the identity property, will be equivalent. All right, I'm going to change my timers here, probably about a minute or so, and then we'll come back together. All right, let's go ahead and take a look at these together. Remember, I might not have yours on here, but as long as you show that you use the identity property, it would be equivalent. So I might start with just multiplying my denominator by 2. Identity property says I must multiply, the numerator by 2. 2 times 1 is 2, and 2 times 2 is 4. So 2/4 is my first equivalent fraction. This time I might decide to multiply by 3. So I multiply my denominator and my numerator by 3. 3 times 1 is 3, and 3 times 2 is 6. So 3/6 is my next equivalent fraction. 1/2. This time I might want to multiply by 8. Multiply my denominator and my numerator by 8. 8 times 1 is 8, and 8 times 2 is 16. So 8/16 would be equivalent. If you have specific questions about this, don't be afraid to ask me in the Seesaw Messenger chat. But as long as you are showing that you use the identity property for the numerator and denominator, your fraction will be equivalent. All right, number 4, I can find the sum of 2 fractions with unlike denominators. Okay, so right away, your mathematician brain is saying, okay, those are unlike denominators. So the strategy that I need to have to give them common denominators and then be able to find the sum. For number 5, the only thing that changes is I can find the sum of mixed numbers or fractions. In this case, it's 2 mixed numbers that you're adding together. Again, it says unlike denominators. So your mathematician brain goes, whoop, okay, here's the things I need to do to add those mixed numbers together. I'm going to set probably a 5-minute timer this time to work through 4 and 5. And then we'll come back together and talk about them. Alright, as things are winding down there, I'm going to go ahead and jump in. Alright, I'm going to start with number 4. So like we said before you went to your independent work time, we knew that these two fractions had uncommon denominators. So we'll need to use the strategy of least common multiple to find out what that common denominator is to be. So I'm going to list my multiples of 3 and my multiples of 5. 3, 6, 9, 12, 15, 5, 10, 15, 20. The least common multiple that they share is 15. So now I need to generate two equivalent fractions that show that common denominator of 15. So 1/3, I'm going to make my first equivalent fraction. My common denominator is 15. 2/5. Excuse me. Where my common denominator is also 15. Alright, so I always have to start with that denominator and say, well, 3 times what gives me 15? If I'm not sure, I can always count my multiples. 1, 2, 3, 4, 5. So I'm going to multiply my denominator by 5. The identity property says I also must multiply my numerator by 5, which would be 5/15. So my equivalent fraction for 1/3 is 5/15. Then I am starting with 5 and I need to get to 15. I can count my multiples. 1, 2, 3. If I wasn't sure of my fact, 5 times 3 is 15, and 3 times 2 is 6/15. I'm going to double check my sign now that I have those equivalent fractions, and I am adding. So I would be adding 5/15 plus 6/15, which equals 11/15. That's a proper fraction, so I don't need to do anything else with it. And my answer is 11/15. I hope that you found the same thing. If not, you can also shoot me a question in Seesaw and we can talk a little bit about it. All right, for number 5, again, before we had some work time, we said, hey, these don't have common denominators. So we're going to use that same strategy of looking at the least common multiple that those two denominators share. Right now, we're looking at multiples of 2 and multiples of 3. 2, 4. Oh, sorry, my pen freaked out there. 6, 8, 10, 3, 6, 9, and 12. The least common number that they share is 6. So we're going to generate two equivalent mixed numbers, in this case, with the common denominator of 6. So 1 1/2, where the denominator is 6. And 6 2/3, where the denominator is also 6. Again, I can count my multiples if I don't know my facts, but 2 times 3 is 6. Identity property says we multiply the numerator by 3 as well, so 3 times 1 is 3. So my new equivalent mixed number is 1 3/6. And move on to my mixed number down below. 3 times 2 is 6, and so I have to multiply my numerator by 2 as well. 2 times 2 is 4. So my new mixed number is 6 4/6. I'm going to check my sign again to see if I'm adding or subtracting. I will be finding the sum with addition. So I would stack this again as 1 3/6 plus 6 4/6. just like adding or subtracting whole numbers, we line up our place value, so the smallest place value being the fractional part in this case to the whole numbers. I'm going to add my fraction parts first, so 3/6 plus 4/6 is 7/6, and 6 plus 1 is 7. So 7 and 7/6, the only trouble with that is 7/6 is an improper fraction. So just like we've been working on, we would take that improper fraction and convert it to a mixed number. We're going to do that by seeing how many whole numbers are available inside of 7/6. So the denominator tells me the whole, so I subtract the whole of 6/6. If I have 7/6 and I subtracted the whole of 6/6, there's only 1 6 left over. Now, there's already 7 as the whole number, and we generated another whole number, so 7 plus 1 is 8, and that would still leave us with the fractional part of 1/6. So our answer would be 8 and 1/6. Hopefully that went okay with you. Just a little bit bigger step there to convert that back to a mixed number. All right, we're going to go ahead and turn the page. Oh, sorry, that flipped upside down. All right, and we're going to take a look at number 6. So it says, I can find the difference between two fractions with unlike denominators. Again, they gave us the hint there in the question that they were going to be using unlike denominators. So this time it's 1/2 and 1/5. It would be very similar to the process on the page before, except instead of finding the sum, you're finding the difference, so a different operation. Number 7 is 5 and 6/7 minus 3 and 2/3. Same thing as before. They don't have common denominators, so what would be your process for that? Just by looking at it, I'm going to say there's probably not any need for regrouping, but it would still be good practice to stack number 7 in case you needed to regroup. All right, I'm going to set another 5-minute timer for you. Again, we'll probably use most of that time to work those two problems, then we'll come back together and talk about it.
Nobody likes to be told what to do, except when someone says, "Hey, eat a Reese's!"
and take a look at these two together. So starting with number 6, like we talked about before you started working independently, 1/2 and 1/5 do not have common denominators. So we're going to give them those common denominators by looking at the least common multiple that they share of 2 and 5. 2, 4, 6, 8, 10, 5, 10, 15, 20. The least common between the two is 10. So we're going to generate two equivalent fractions with the common denominator of 10. 1/2, and we say, hey, you must have the denominator of 10 now. And 1/5, you must also have the denominator of 10. In order to make that happen, we'd have to multiply the denominator by 5. Identity property says anything we do to the denominator, we must do to the numerator. 5 times 1 is 5. 5 times 2 would give us 10, so we must also multiply the numerator by 2, which would be 2/10. Now that we have two equivalent fractions, we would be taking 5/10 and subtracting 2/10, which would leave us with 3/10. So our answer is 3/10, which is a proper fraction, so no other work needs to be done. Alright, moving on to number 7. Same process, except we have mixed numbers here with the fractional part and then the whole number part. Same thing. We know they don't have common denominators with 7 and 3, so we are going to use the strategy of looking at their least common multiple of 7 and 3 to generate those equivalent fractions. So 7, 14, 21, 28, 3, 6, 9, 12. Remember, if I haven't found that least common multiple, I might just have to keep going and see what I can find. So 15, 18, and 21. There is our least common multiple of 21. So we'll generate two equivalent fractions. We'll mix numbers truly, so 5 and 6/7. And 6/7 must now have the common denominator of 21. 3 and 2/3, and that fractional part must have the common denominator of 21. 7 times 3 is 21, so that identity property says, well, 6 times 3 is 18. So we have the new mixed number of 5 and 18 21sts. And then 3 times 7 is 21, so we multiply the numerator by 7, which is 14. So now we have 3 and 14 21sts. I check the sign. I'm still finding the difference using subtraction. Just like whole number subtraction, I start with the smallest place value. In this case, that's the fractional part, in case we have to regroup. However, we're lucky because 18 minus 14 is just 4 21sts, and 5 minus 3 is 2, leaving us with 2 and 4 21sts as our answer. Alright, moving on from those surface level type questions, we're moving on to those deeper level questions. Know that they're probably going to ask us to justify or solve two-step problems. So I can use estimation of sums or differences of fractions or mixed numbers to explain the reasonableness of my answer. Okay, so this is a lot different than what we saw on our mid-module assessment. So this one, it says if 2 and 1/2 and 1 and 1 is 2 and 1/2 and 1 and 1/5 equal to 3 and 2/7. Justify your answer using the identity property and equivalent fractions. So this one's asking you to solve it. See if adding 2 and 1/2 and 1 and 1/5 truly does equal 3 and 2/7. If it does, then you would give a sentence justifying your answer and how you know that. If it does not equal 3 and 2/7, you'll also write a sentence justifying your answer about why it isn't. I would still show my work here. You'll just be using that writing part of like RDW that we normally use for word problems. You'll just using the writing part, writing that sentence and explaining it on how you got that answer. So maybe just about, I don't know, a 3-ish minute timer there to look at this one, and then we will talk about it together.
New Mucinex Kickstart gives all-in-one and done relief with a morning jolt of instant cooling sensation. It's comeback season.
Alright, I'll save you from the annoying beeping there. Alright, so I would have been looking at 2 and 1/2 and 1 and 1/5, and right off the bat, mathematician brain is saying, whoa, those don't have common denominators, so I would look at my least common multiples of 2 and 5. 2, 4, 6, 8, 10, 5, 10, 15. The least common is 10. So I would generate an equivalent fraction of 2 and 1/2 with the common denominator of 10, and 1 and 1/5 with a common denominator of 10. I'd have to multiply 5 times 2 to get 10. So 2 times 1 is 2. So now this is 1 and 2/10. 2 times 5 is 10. So 5 times 1 is 5. So now this is 1 and 5/10. I'm going to go back and look, and it says I am adding those two. So 5 plus 2 is 7/10, and 1 plus 1 is 2. Okay, so I got 2 and 7/10, which is very different. Oh, I just noticed I made a mistake. That's a whole number of 2. That's a whole number of 1. I wrote 1 here, so this is a 2. 2 plus 1 is 3. Glad I noticed that. Sorry about that. So 3 and 7/10 is a lot different than 3 and 2/7. So I'm going to be kind of looking at it here and seeing what they might have done. So to me, what it looks like is they just added these denominators because 5 plus 2 is 7, and then just added the numerators 1 plus 1 and being 2. So it looks like they just added those across. So I would justify and say, no, the sum of, gotta erase my circling there. It's too much circling. The sum of 2 1/2 and 1 1/5 is 3 7/10. They did not find common denominators. I'm squeezing this in, sorry, before adding. I would normally write out denominators, but I had to really squish it in. Okay, just a sentence there that explains, hey, answers the question, no, it does not equal 3 2/7, and then a quick explanation of why it does not. All right, the next one, I can apply my knowledge of finding sums and differences of fractions or mixed numbers to solve multi-step word problems. So a couple things here. John used 1 3/4 kilograms of salt to melt the ice on his sidewalk. He then used another 3 4/5 kilograms on the driveway. If he originally bought 10 kilograms of salt, how much does he have left? I'm going to be looking for a couple things here. My first is our strategy that we always use to solve these multi-step word problems. I'm going to circle that important information. 1 3/4 is what he used. He used another 3 4/5. He originally bought 10. Okay, I'm underlining the question. How much does he have left? I'm going to box in any operation clues. Used another makes me think that I'm going to be adding that on to what he used. And then how much does he have left over? That makes me think I'm going to be finding the difference from what he used versus what's left over. Okay, so now it's on to you to set up those equations and solve, and I will set just a little timer, and then we'll come back together and talk about it. So go ahead and try to solve from there. We know it's at least 2 steps because there's 2 operations, and then we'll check back in just a minute. Let me see if I can find one that doesn't have sound. I know that's probably getting a little annoying at this point. Let's go for 2 minutes this time, since it's just the one problem. And let me make it with no sound. There you go. All right. Nice quiet countdown for you this time.
Cough and chest congestion relief that goes the distance. Mucinex DM.
All right. You should be good to go. All right, let's go ahead and take a look at this one. All right, so the first equation that I would have been setting up is we said we wanted to add together what he used the first time, so 1 3/4, plus the other part that he used, which was 3 4/5. That's my first equation. And I'm going to go ahead and draw a line because I know over on the other side I'm going to be finding the difference. All right, so 1 3/4 plus 3 4/5, as much as I'd like to just add those, they don't have common denominators. So I'm going to use the strategy of least common multiple to give them a common denominator and make those equivalent fractions. So 4, 8, 12, 16, 20, 5, 10, 15, 20. So 20 is the least common that they have in common. So I'm going to take 1 3/4 and generate that equivalent mixed number in this case, where the common denominator is 20. And 3 4/5 and give that the common denominator of 20. I'd have to multiply 4 times 5 to get 20. Anything I multiply the denominator by, I must multiply the numerator by. So this is 15 20ths. So now I'm looking at 1 and 15 20ths. And then 5 times 4 gives me 20. So 4 times 4 is 16. So now this is 3 and 16 20ths. Checking back my sign, that is addition. So 15 20ths plus 16 20ths gives me 31 20ths, and 3 plus 1 is 4. The problem with leaving 31 20ths is it is an improper fraction, so I would subtract 1 whole and see what's left over to see if I can make that mixed number. So 31 minus 20 would leave me with 11 20ths. Because I was able to find 1 whole, and they already had 4 there, I'd have to add 4 plus 1, which would be 5, in my fractional part, which is 11 20ths. So 5 and 11 20ths on this side. Okay, that was my step 1. But step 2 is how much I have left, and we found how much he used all together. So we'd have to take what he started with, which was 10, and that's a whole number, so there's not any fractional parts here. And I could put 0 over 0. Or I could put 0 20ths because I'm going to be subtracting what he used, which is 5 and 11 20ths. Okay, that's my second equation, so I can check that off. And I'm solving it, so let's check that off. All right, just like in whole number subtraction, I had to start with the smallest place value. In this case, this would be the fractional parts because they're less than 1. If I have 0 zeroths or 0 20ths, depending on your preference, doesn't matter which one, 0 minus 11 I can't do, so I have to go back just like in whole number subtraction. I'm going to take away 1 whole this time, so now there's only 9 wholes left. I'm bringing back 1 whole, so the denominator says the whole is 20, so 1 whole is 20 20ths. 20 20ths plus 0 20ths is still 20 20ths. Okay, something that I noticed on the exit tickets from last week, and I know we haven't been back together to look at those again, is a lot of you are forgetting this step. You're writing the whole, but you're not adding it together. This time we're lucky because there's 0 here. But for example, if there was 2/3 there, I would need to add that part that's already existing to the part that I regrouped. Anywho, 20 minus 11 would give us 9 20ths. And then I can subtract those whole numbers. 9 minus 5, which would give us 4. Okay, so how much did he have left? John has 4 and 9 20ths kilograms, oopsies, of, and this was salt, right? Yep, of salt left over. Perfect. All right, moving on to the last page, last but not least. This is going to look very different because this was not on your mid-module because we weren't quite ready for those transfer level questions, but now that it's our end of module assessment, we're ready to take a look. All right, so this one you're going to evaluate the work of others' solutions, and then you need to identify the mistake that's made, and then you're going to make corrections and then justify those corrections. So let's take a look at the problem first. It says Jamie needs 7 pounds of sand to fill a sand pit for her kids. She found 2 bags that each weigh 1 1/4 pound, in another bag that weighs 2 2/3. Does she have enough sand to fill the pit? Review the work below and identify the mistake within the student work shown. Okay. Then 10B, it says correctly solve the problem from 10A, then explain the error within the student work above to justify your corrections. Okay, so the first one, it says review the work and identify the mistake. So there's some work here on this paper. It already tells us it's incorrect, so there has to be a mistake. So I would circle anything that I think looks maybe like a mistake, or I might use the strategy of I think I would rather solve this myself, so go down to 10B, solve it myself, and then come back and compare the work to my work to the student work and see if I could circle the errors there. I'll leave it up to you. It's your choice. I know I personally am going to start with solving it the way I would solve it and then going back and looking for the errors. This one might take you just a little bit longer. So I'll give you another extra minute or so, and then we'll come back together and talk about it. All right. I'll see you on the other side. Let's see. Let's do 4 minutes this time. And I'll give you no music. And
Mucinex Night Shift fights your worst nighttime symptoms, so you can get to sleep and wake up ready to go.
How could you?
and we're off. Stop that beeping. Sorry about that. All right. First thing I would have done is I would have solved for cubes, so hopefully you did too, and broke this apart to make sure I was ready to answer this question. Start by circling that important information. 2 bags that each weigh 1 1/4 need 7 pounds. Another bag that weighs 2 2/3. Underline the question, does she have enough sand to fill the pit? Box in any clues here. So I'm going to box in 2 bags of each. That probably means I'm going to be doubling it or adding those 2 together. And then it says another bag that weighs 2 2/3. So I'm going to need to add that. But then if it says, does she have enough? I'm going to be finding the difference of the 7 pounds here. So I'm going to be subtracting. Okay. So I'm ready to start with my first equation here. So 2 bags that each weigh 1 1/4. So this bag weighs 1 1/4. But this bag also weighs 1 1/4. And then she found another bag that weighs 2 2/3. Okay. So that's my equation for right now. I know there's a second step, but I can make this a little bit easier for myself because 1/4 and 1/4 have common denominators. So 1/4 plus 1/4 is 2/4, and 1 plus 1 is 2. So now that's 2 2/4 plus 2 2/3. Now I have fourths and thirds, so I'll need to use least common multiple to find them common denominators. 4, 8, 12, 16, 3, 6, 9, 12. Their least common multiple is 12. So 2 2/4. And I'm going to generate an equivalent fraction where the denominator is 12. And 2 2/3, I'm going to make that equivalent fraction where the denominator is 12. 4 times 3 is 12. Identity property says that I have to use 3 times 2, which is 6/12. So now this is 2 6/12 plus 3 times 4 is 12. Identity property says, well, that has to be 4 times 2, which is 8. So now it's 2 8/12. Add my fraction parts together. 8 plus 6 equals 14/12. And 2 plus 2 is 4. Problem with that is 14/12 is an improper fraction. So I'm going to take out 1 whole. That would leave me with 2/12 left over. Oh, I wrote 14/14. I meant 12/12. The whole comes from the denominator, not the numerator. Sorry about that. So then that's 2/12. So now I have 4 plus 2/12, which is 1 whole. So now it's 5 2/12. All right. So now I need to go back and check in and kind of see where I'm at. We added these 2 bags together, the other bag here. But the question is asking us, does she have enough to fill the pit? And she needs 7 pounds. Well, looking at this, if she needs 7 pounds, she only has 5 2/12. It doesn't ask us how much she has left over. It's just asking us, does she have enough? Well, she only has 5 2/12. The answer would be no, she doesn't have enough sand. But going back up here, it says I need to go back and identify the mistake, then explain those corrections and justify it. Okay, so let's look at the student work and see where we went. Okay, so 2 2/3, 2 2/3, that's fine. They added the 1 1/4 and 1 1/4. But when they added 1 1/4 and 1 1/4, they got 4 2/4. To me, it looks like they added, I'm not even sure what. 1 plus 1 would be 2. So I'm not sure how they got 4 2/4. So that's definitely a mistake. Then I'm looking at 4 2/4 and 2 2/3. And it looks like they added those together, which we would have added them together. However, they added 2 plus 2 and said that was 4. And 4 plus 3 and said that was 7. Instead, they would need to find the least common multiple. Then everything else has to be incorrect from there because they didn't follow that process. So we need to explain it and say, first of all, Jamie would only have 5 2/12, and I believe this was in pounds. Is that correct? Yeah. We only have 5 2/12 pounds of sand. She would not have enough to fill the pit. The student made the mistake by adding fractions without making common denominators. Okay. All right, so that should wrap up our review. Your assessment for the end of module will look very, very suspiciously similar, maybe just some different numbers. So making sure that you understand every strategy on here is key. I'll be available over Seesaw for any questions that you might have, and we can do a few more practice problems if there's anything that you're confused on. A couple of reminders to complete the rest of your Seesaw activity. Go ahead and take a picture of your completed review. You can do each page and upload that into the Seesaw activity. And then on the next page, it gives you a reminder about iReady. It is a new week, so you'll need to get your 15 minutes of iReady math today. Just set your timer, get your 15 minutes in, and then you are finished with math for today. Our goal will be to take the mid-module when we return back to school. So again, hopefully I see you Wednesday. I hope you're staying safe and warm. I miss you a whole lot, and I hope you're doing well, and I can't wait to see you. Thanks for working hard today, and don't forget to reach out if you need anything. Talk soon.